Hey guys, so Dr. C here, and so we're going to be doing part 3. So this is our day of our quantum mechanics lab. And so today we're going to try to find Planck's constant. So you have all these constants that are in the back of the book, all these constants that we kind of tell you have to know and memorize, but where do they come from? How did we derive these constants? How did Planck find this constant back in the day? And so what we're going to do is we're going to do an experiment to show you how you can find Planck's constant using the experiment and then using math. So how is this all going to work? So if we remember the equation that we have, it's in our introduction in your lab manual. E is equal to hc over lambda. E is energy, h is Planck's constant, c is our speed of light, and lambda is our wavelength. So what we want to know is we want to find h. C is another constant which you can find in another experiment, but we want to find E and lambda. So what we're going to do with our setup here is we're going to use different wavelengths in our photodiode panel. So we have different wavelengths, so we'll change the wavelengths, and we're going to figure out what, based on which wavelength we're at, how much energy is associated with it for our light to light up. And so we'll have our power supply and we'll have our multimeter, and this is going to read the voltage. So we're going to measure the voltage and the wavelength. So that's E and that's lambda. So once we have E and we have lambda, we can find H when we graph it. So that's how we find the correlation, which is Planck's constant. So first thing we need to do is we need to set up all this madness, right? So I have the procedure, so I just pull out the procedure, I'm going to read through it. So there's 4 working pieces. So like I said, we have our DC power supply, our multimeter, our photodiode panel, and then we have a bunch of little connectors. So little connectors so that they can have all power running through. So the first thing is we want to plug in our power supply to the outlet, check, and press the power button. Ta-da! All the knobs need to be turned off. Got a little bit of voltage, but it's really small, so it's okay. That's just telling me it's on. All right, and so once they're all turned on, now we want to adjust it, because right now we're on CC. So we're on current, but we want to be measuring voltage, because remember I said we want to measure the voltage, the current, not the current, but the current voltage. So I'm going to adjust this knob just a little so that it kicks over to my voltage. So now I'm set up for measuring voltage. And now we're just going to focus on my voltage knobs, and we won't mess with those unless it accidentally kicks back. Then I'll kick it back the other way. Then it says that we're going to use an experimental lead to connect the negative output on the DC panel supply to the negative output on my photodiode panel. And there's a picture that's in your lab manual for this experiment, and I'm pretty much setting this up. So this is the picture, and I'm telling you the words of what we're about to do. Okay, so it said negative output to negative. So I get in cord, and we're gonna go negative for my DC power supply. And so there's a negative right here on my DC power supply to the negative that's on my photodiode panel. So negative to negative, okay? Then it says to use a second experimental lead to connect the positive output on the DC power supply to the 465 nanometer or 20 milliamps positive output on the photodiode. So positive to positive. So here's the positive. It's red, so I match up my colors. It also kind of helps. Red, and it said to go to the 465. So that's going to be my first one, my 20 milliamps or my 465. We're not so worried about the milliamps, but we want the wavelength, okay? So that's the next one. All right, so this will read voltage, but it's not going to read it as accurately as my multimeter will read it. So what I want to do is I want to set up my multimeter to my power supply and to my photodiode panel. So to be able to do this, it says to connect the COM input on the multimeter to the negative input on the DC power supply. So literally says the word COM. So from COM to back to my negative, hence the black. So the negative. And they actually go on top of each other. So you can put multiple on top, back to back. All right, and then we need to attach, I lost my place. And then we want to do the voltage, so we want to go from voltage on my voltmeter to the positive part on my DC power supply. So voltage to the positive. So red, red. All right, so now I've got all my cords, I've got it all set up. Now I want to turn on my voltmeter. So I want to turn it on so that I can see the voltage, because remember that's what we're trying to measure. So I'm going to turn it so it sees voltage. All right. Now you think it says 16.2. It says millivolts right here. So we're in millivolts first off, and it actually is a negative. So I'm pretty much close enough to 0. So it should read 0 or just in the negative, and that's fine. So if we look at our diagram, I go from the COM to the negative, and then from the voltage to the positive. So from the COM to the negative, from the voltage to the positive. And then from the negative on my power supply board, on my DC power supply, to the negative on the photodiode, and then positive to the photodiode. So negative on my DC power supply to the negative, and then positive to my photodiode board. All right, so we're all set up. So it says to not proceed until you have approval of your instructor. Well, since I'm the instructor, I think we're good to go. The most important part is to never exceed 5 volts. This is really sensitive equipment, so we don't ever want to go too far because these are little LED lights. And if we put too much voltage, we're going to blow our LED lights. So we want to be careful that this never goes above 5. You can get close to it, but we don't want to exceed it. All right, so now this is when we're going to start. So now that we have everything plugged in, now we want to be able to actually do our experiment. So I got all my stuff. I'm going to slide this over so that you can see it easier. Okay, and now you can see your piece of paper because now you don't care if my cords are all tangled. All right, so in this part, you have your data table here. We're going to be filling in the wavelength, the color, and the voltage. So the wavelength corresponds to the number that my diode is plugged into. The color is going to be the color that you see when we light up the LED light, so they're going to be different colors. And the voltage is what you're going to read off the voltmeter. These 2 columns we'll do in the next video when we do our calculations. All right, so let's do the first one. So the first one you want to write it down is 465 nanometers. All right, so it's at 465, and so now we're going to slowly change our voltage until our light lights up. Okay, so we just want to be very careful because we don't want to go over 5. Oh. Kicked over. All right, we're okay. And if you look, it lit up. All right, so awesome. So now it's lit up, so you want to now write the color down on your data sheet. All right, so now that it's lit up, don't write this voltage. What you want to do is now we want to turn it so it's barely on. Right whenever the light turns off, that's the voltage we want. So now we want to turn it off. So we want to get to the very minimum amount of voltage. So you can see it's on, and so I'm just going to slowly get to where it's turning off. So I adjust the coarse knob, and then I'm going to adjust the fine knob so it's still on. And sometimes it helps to put your hand by it. Let's check. All right, I think that's it. So now you want to copy down the volt number. so now we're gonna repeat the exact same process, but this time, let me turn it down. We're gonna switch to go to our next wavelength. So now we're at 560. So that's your next wavelength. So you wanna write that wavelength down. And then we're gonna do the same process. I'm gonna slowly turn up the voltage until we see the color. There we go. So at this point, you should be able to record that color. All right. And now we're gonna go till it just barely is on. So now it's on. Put my hand. All right, I think that's where it's just barely. And so now you can record that voltage. All right, same process. Do the next one. All right, this one is 585 nanometers. All right, we're gonna turn it on. Light up our light. There we go. Nice and bright so you can see the color. So write the color down. Okay. Then we're gonna go until it turns off. So you can see it's on. All right, right there. Okay, adjust our voltage back down again. Move to the next one. So now we're at 635 nanometers. All right, slowly adjust our voltage till we see the color. All right, you can see the color, nice and bright. Then same process, we want to go until we can't see it. Okay. Record that voltage. All right. Bring it down. Then we're gonna do 660 nanometers. Okay, turn it on. Okay. All right, and then same thing, we want to go down to where you could barely see it. Nope, let me adjust the other knob real quick. Oh, I adjusted it too much, hold on. This one's being finicky. Okay. Okay, so we're gonna turn our voltage down And so the last one we're gonna do is 950 nanometers. Now this one is in the infrared, which means we're not gonna be able to see the color or see it being lit up with our eyes because it's not in the visible light spectrum. So I'm gonna have to get a cell phone so we can see it. So in the next video, we'll do our infrared light.